Hello and welcome back. On this particular episode, I'm actually going to be looking at debugging a little bit. Now, if you recall, when we ended our last episode, the mega episode, hour long, we basically built up most of the functionality we had left. There was an error. It was definitely an error that we were saying. And let's see if we can go ahead and reproduce this error, right? And basically what happens is we go ahead and you add a card, right? And let's say another 2 cards, right? And then we go ahead and we decide we want to save our board, okay? And then we go ahead, okay, delete board. There's one left. There's one left. So the question is, what is causing that? Now, I'll let you in a little bit of a secret. I figured it out already then. And I may even mention a little bit hint to what I think was going to be the issue before we even got the issue. But this is, in fact, it just happens to be, just from experience, I can tell you more or less, we are running into what we call a race condition. Now, I will tell you, one of the hardest, most difficult issues that comes up in any kind of development, that essentially involves threads. And with CLOG, everything is threads, right? Everywhere you look, you're working with a multi-threaded application in everything you do. And of course, that gives you some of the coolness that CLOG offers, but it also presents us with some of the problems, right? So now again, we go to our code. By the way, apparently the code didn't save quite right before I put it in Git. So basically, I went ahead and this may be slightly different. It's same code basically. For saving, I remember doing something slightly different. So you see a slight change in the code. It's not code any functionality. I made sure not to change that. But again, I just lost some code at some point by not saving. My bad. Okay. Anyways, but of course everything is in Git. I don't know if I mentioned that before, but if you go to my Git in the CLOG-Plunger repository. Now, okay. So basically, let's take a look and see what's going on, right? Here's our code, right? In fact, it's even a little bit more difficult to ID exactly what's going on. So we have a hash, right, that stores all of our cards, right? And I'm going to show you something else. So of course, one of the things I would start doing in a situation like this is I'd start playing around and see, well, okay, was it really about the loading and saving? Or maybe it's something else, right? Maybe there's something else that's causing it. Well, that seems to work, right? Like what exactly is the error, right? Okay, that's fine. Now, happens to be, I'm pretty sure now this is going to create the error. There's the error. See? So we know it's nothing to do with loading and saving. It has to do somehow. Here, we're going to basically lose track of what cards are actually stored in our board. And I did mention it that we're going to need to come up with, at some point, a better way to be able to create our IDs. The card ID, right, that we generate has to be unique. We're sticking them into a hash. So basically, that hash table, as it's building up, if I replace something in the hash table with the exact same card ID, it will disappear, right? Or in other words, one of them will be overwritten, the other one will remain on the screen, but is no longer contained in our hash table. So the question is, where did we create ID? Well, of course we recall, it's still in a small application. And if you take a look at our board frame, I actually want to get to the board, card board. Here we go, right? So we have our make hash table test. That's the actual hash table. So where are we making our IDs? Oh, sorry about that. Not sorry about it. This is how we learn what's going on. So I must have created in the actual card itself. Where we get our ID first, right? Create index card. Oh, actually, this is the actual. So wrong thing. I mean card body. There we go. Make resizable. Make card data. Set data. Unload. Unsave. Undelete. Unclick card. Right. So where do we set our original card ID when we create the application, right? Let's see here, card index. There we go. That's our card ID, right? It's in the index card. I thought I went for the board by mistake instead of the card. So that's why I thought it was right. So we're doing this in our slot. Okay, so basically our problem here is right here, get universal time. Universal time is only accurate basically to, I think it was thousandths of a second. And the problem with that, of course, is if you make 2 clicks, one after another, we actually create 2 cards with the same ID. So really, like I said, it was probably bad form for me to begin with to actually put code here in my init form and not put it somewhere in the body. This way we would have tracked it down easier. So first of all, let's get rid of this. And let's see here. We're going to create, basically, we're going to tell we want it to be in our plunger new card ID. Okay. So that's first of all. And, right. Okay, so let's go ahead and save that, right? Whoop. Make sure. What happened? Oh, undefined. That's fine. We don't mind that at all. We're good. Okay. So, okay. So let's go ahead. You'll notice the error actually shows up in 2 places. During the compile, it showed up here in the builder, and during the runtime, the error showed up in Emacs because that's where I started started the builder from Slime. Okay, so let's go ahead now. We can close this new card ID. Actually, let's just make sure. Let's be nice and do copy and paste. Okay, and let's close this out. Okay, and card body. And here we go. So here, let's go ahead now. Yeah, we'll definitely create a def method because we may at some point use some inheritability in this. Okay, card, index card. Okay. Okay, so now our original code, of course, was to return a an ID based on get universal time. And get universal time. Now, I actually, the truth is, it's not a ridiculous way to do it, but there is one thing we could do that would actually improve things a little bit. That is, any time we're, of course, running this application, unless we're really talking about using this someplace else, meaning where these IDs have to be unique against everybody on the planet, but it really doesn't need to be unique in terms of everybody else, just unique in terms of our application. So let's do this, right? Let's go ahead and let's do format, right? And it can be a string here as well that we return because it really isn't. It's not used for anything other than identifying our particular card. And we've already established, by the way, if you recall, I don't know if you do, but I'll let you remind you about this. When I set up the card, when we set up the board, which contains the hash uses equal or equal p. So basically, I don't recall. I think it was equal, but either way, it basically we have a comparison that's going to be compatible with strings. So we can use even a string here, and it won't matter. Let's just double check, right? That's always a good idea. Okay, what happened here? Here is my board. 1 second. Sorry about that. I try not to do that. I try and keep you guys live the whole time I'm working. That actually was very foolish of me. There was an error before, and I forgot to abort it. So it actually was creating, interestingly enough, another race condition. Interesting. Okay, something I have to look in for the future. We'll talk about that another time. Okay, so basically, if you notice here, we basically use test of equal p. So we're just kind of confirming that, and we know we're good to go with that. Okay, so now let's go here and go back to our code, our change. Okay, we started working on that here. Okay, so def method. Yeah, again, I had stopped everything in the middle. Card index, card index card, right? And use get universal time. Okay. All right. So what we're going to do basically, in order to, we're going to return an ID now. That's going to do what we want, which is basically format nil, and we're going to grab the universal time, and then what we're going to do is we're going to add a essentially a sequence, card sequence, right? We'll go ahead and do that, and we're going to do this. That would be a bad idea. You know, actually, we could use this. We could still use this. Now, you remember, we got to. Let me show you what I was going to do originally, and we will still may make some changes. All right, and I'm going to show you what we're going to do to solve that. Right. So, first of all, def parameter. We basically are going to go ahead and we're going to make card sequence a. Again, this is what I was originally going to do. And basically the idea is we're going to just add 1 every time we do this and basically end up with the next card number in sequence. So we could still be creating a race condition. That's the reality here. So again, you know, the card sequence, you know, we're looking at increasing it every time we make use of it. So we end up with this very unique ID that's based on time and some unique instance of the cards on the page. And that does work. But again, somebody hits plus, keeps adding numbers fast enough, then this number, you know, it's not going to change if it's a single user, but multiple threads could potentially create that. So, solutions. So, first of all, one solution is to essentially use what is called atomics, right? So I have an atomic. I basically can use it. This can only be changed, meaning whenever it's being changed, it can be changed only by 1 thread at a time, because this value is atomic, meaning any access and any input or output from the card sequence number would become atomic. So I'll actually show you what that looks like. This is using the atomics package, which is really nice for pretty much opening up atomics across multiple implementations, because there are differences between the different lists. So so basically, and you would go ahead and you do what's called an atomic increment, right? And in order to do the atomic increment, it has to be done on a list. So that means to say that I have to go ahead, or I have to make sure that we set it up. This, by the way, is from the CLOG connection where I do use atomics there. So that's one possible solution for this, and that's certainly a very valid solution. The other possibility, what I wanted to show you is actually, where was I? Oh, here you go. So let's go to the definition. I just want to show you that it seems a little bit convoluted, but there are internal reasons as to why it has to be done this way. But new ID basically ends up, again, it's a list in this case with one particular value, and the car basically of this list is what we actually update. And again, this just has to do with the way the implementations work when you are using atomic values. So that's one way. The second way basically is essentially to control the threads, control access to the information, which essentially means we're going to use what's called a mutex. So a mutex basically would say, hey, only 1 thread at a time gets access. Now, there is one other thing we can do, which is actually what we're going to do. Is I'm going to reuse code that already exists. So one of the neat little things, I have actually 2 different functions in CLOG connection, right? Which is the underlying, like the lowest level of CLOG, and that's the portion that makes the connections back and forth to the browser to your machine. So one of them is we could use just generate ID, and we could actually then use the code that we started writing over here, and just essentially do generate ID every single time. But actually, you know what? Let's just actually throw in the code that I'm actually using, which is random hex string. In other words, we can go ahead and we can make use of this from the very beginning, right? To give a unique ID that is not based on time or anything else, but essentially based on a cryptographic grade ID that we basically will give to every single card. And that solves a lot of problems. Every card unique, and that will be a really great solution. So we're going to go with that. And actually, new card ID is actually just going to return our random hex string. And we're going to have to give it the package. CLOG connection. All right. And random, it's a turtle thing. Random hex string. Okay. Yeah, that's actually, we saw our value here was that's it. So we can actually make use of the very code that generates for CLOG itself. And let's go ahead. Now we do like that. Okay. So let's go ahead and save that. All right, and let's go ahead. At this point, let's first of all value it all. Make sure we don't have any mistakes in here. That's great. Then we also have the actual the card itself, right? We go ahead and value it all. Once the new card ID is called with 0 arguments, right? And so good thing we ran that. Oh, by the way, what I did was, if you notice, I opened up the card, the actual rendering, and ran that. So we can take a quick look and see if there's any problems. So what's going to happen here is our new card. Yeah, I said I wanted to make use of, from the beginning, make it a method that was be able to override. It's not going to work out very well. So let's go like this. Let's make it a function. Okay, and new card ID. All right, and I think we're going to go with that. And that's basically it. Now, one more thing. Let's see. CLOG new card ID defund. Okay, that's fine. I think we're okay at this point. Let's go back here. Eval, fine. Now, okay, I think we're. Oh, CLOG Plunger. No, that's not the one we want to update. This one, eval list. Okay, fine. All right. In fact, you know what? Let's actually do something else. Let's unload the entire project for memory. Oops, let's memory, okay. And let's go ahead and reload our CLOG Plunger. Just make sure everything is as fresh as can be. And we have a problem. New card already names in order. Okay, so we're actually have to do a little more than that. And I found that's one of those type of things that, yeah, I can either use code to make this all work out. To redefine everything as far as CLOS is concerned, but we're going to go ahead because this is the way I would do it. I know it's not the best way or the technically correct way, but I'm just going to start again. But I generally do that when using when you make a major change like that in class and in your classes. Again, I just redo the whole thing and finish. Grab the brand new image, and then we're fine. And we can go ahead and we can test now. File, new free when. Okay, add badge. Okay, something went wrong. All right. All right. New card ID requires at least one argument. Where is that the case? All right. Where is our card? Oh, that's why I didn't. That's not good. There we go. Let's do that. And this, I guess we didn't save it before. Okay, defund new card ID. Save. All right. And let's start over again, like I said. I guess you get to see the worst of the worst today. That's not a bad idea. Seeing the worst is not a bad idea. Bad idea at all. Okay. So CLOG Plunger. Perfect. Okay, run. File, new free win, and there we go. 1, 2. So I did a whole bunch of them. Okay. Now let's go ahead and save our board. Truth is, I don't really have to save our board. We can just see if it all deletes. Aha! So we already know where. There you go. 1, 2, 3. And anyways, I'd like to see what it looks like inside, right? So let's go ahead and let's save our cards. All right, and let's go ahead here and open up a source editor, and let's go open file, and okay, here we go. Let's grab our file. Let's take a look and see what it looks like. So there we go. Okay, so basically you see again we have these nice little unique IDs that are going to be unique even across machines. So that's actually a really great option we've added. So again, we could have basically, like I said, we could have made it work with either atomics or mutexes, and basically end up with something that looks like a universal time plus some other digit afterwards. But this gives a completely universal, and we may actually want to have a creation date and other things later on. But this will do it for us. So we're good to go.